This is the Nexora Weekly Edition. Over the last 7 days, technology moved across artificial intelligence, hardware, robotics, and the products people use every day. We reviewed the week's reporting and selected 11 distinct developments. Here is what happened, why each story matters, and what could change next. This week, the tech world is buzzing with a mix of fear and fascination as AI companies push the boundaries of what's possible, while also raising eyebrows with their promises and warnings. The narrative around AI has shifted dramatically, with some companies leveraging public anxiety about AI's potential to control or dominate, echoing the dystopian visions from movies like The Terminator. This isn't just about technology anymore. It's about power, control, and the future of work. As AI models like Opus 5 are released, they're not just tools, they're reshaping industries, from how businesses operate to how we interact with technology. The implications are vast, affecting everything from data privacy to job markets. Meanwhile, the push for local AI solutions, like running AI on humble hardware, is gaining traction, offering a counterpoint to the centralized tech giants. These local AI initiatives, such as OpenClaw, highlight the potential for decentralized computing, where users can run complex AI tasks without relying on cloud infrastructure. However, the real-world consequences of these developments are significant. For instance, as companies like those mentioned in the Washington Post are poaching top economists, the landscape is shifting toward a more data-driven and algorithmic economy, where AI is not just an enabler but a central player. This shift raises concerns about regulatory capture and the concentration of power in the hands of a few. Understanding the balance between innovation and regulation is crucial, as these developments impact everyday users and businesses alike. As we move forward, the key will be understanding the balance between innovation and regulation, and how these developments impact everyday users and businesses alike. This week, NVIDIA made waves by open-sourcing its first GPU-accelerated medical physics simulation framework, marking a significant step in the intersection of AI and healthcare. The move comes as part of a broader trend, with NVIDIA leading efforts to bolster open-source AI security, following a recent hack on Hugging Face. This initiative underscores the growing importance of transparency and collaboration in AI development, especially in high-stakes fields like medicine. By providing tools that can simulate complex physical processes, NVIDIA is enabling researchers and clinicians to test and refine treatments in a virtual environment, potentially reducing risks and costs associated with real-world trials. The impact could be profound, from accelerating drug discovery to improving surgical training. The framework leverages NVIDIA's advanced GPU technology to accelerate simulations that would otherwise require extensive computational resources, making it a powerful tool for medical research. A real-world consequence of this development is the potential for more accurate and efficient preclinical testing, which could lead to faster approval of new therapies. In comparison to traditional simulation methods, NVIDIA's framework offers a significant performance boost, enabling more detailed and realistic models of biological systems. As the open-source community continues to grow, the challenge remains in ensuring these powerful tools are used responsibly. What's next? Watch for more developments in AI-driven healthcare innovation and the ongoing efforts to secure open-source platforms. In the world of self-driving networks, a new challenge is emerging that could redefine how we think about system reliability. These networks, designed to operate autonomously, are now facing an issue known as code drift, a phenomenon where multiple components degrade simultaneously, making it difficult to pinpoint the root cause of failures. This problem is particularly concerning because it can lead to mission-critical failures without a clear single point of blame. The issue stems from the assumption that hardware remains in its original condition, which is no longer valid as systems age. Batteries degrade, sensors drift, and memory reliability declines, creating a mismatch between expected and actual performance. This growing gap can lead to what's called agnostic collapse, where failures are attributed to accumulated degradation rather than specific component faults. The real-world consequences of code drift are profound, as it can lead to system-wide outages in critical infrastructure such as power grids, autonomous vehicles, and industrial automation. For instance, a sensor drift in a self-driving car could be misinterpreted as a software bug, delaying critical safety responses. To address this, researchers are developing frameworks like Aging-Aware Autonomous Intelligence, AAAI, which integrates hardware health into decision-making processes. By continuously monitoring and adapting to hardware changes, These systems can maintain reliability and prevent catastrophic failures. The mechanism behind AAAI involves hardware self-awareness, which uses physics of failure models to estimate the health of power, sensing, memory, and computation subsystems. This proactive approach enables systems to anticipate degradation and adjust their operations accordingly. The implications are significant for industries reliant on autonomous systems, from transportation to energy, where downtime can be costly. As these technologies evolve, the ability to predict and mitigate code drift will be crucial for ensuring the safety and efficiency of self-driving networks. In the summer of 2026, a growing movement on Reddit and beyond began to frame AI not just as a technological shift, but as a societal threat. The narrative centered on the idea that widespread public hatred of AI could lead to regulatory capture, censorship, and even a totalitarian future. This wasn't just about fear of surveillance or job loss, it was about the perceived erosion of free will and the commodification of human labor. The argument was that by using AI for free, users were effectively weakening the economic moats of the companies that built it, making it easier for those companies to outsource tasks once handled by employees. This created a paradox. The more people relied on AI, the more they undermined the very systems that could make AI sustainable. The movement called for adaptive resistance, not outright rejection, but the challenge was clear: how to fight a system that thrives on scale and efficiency while protecting human agency. The real question now is whether this resistance can evolve into a sustainable model, or if it will be co-opted by the very forces it seeks to challenge. The mechanism at play here is the economic model of AI development, which relies on the commodification of human labor and the extraction of value from data. As companies scale their AI operations, they create a dependency that makes users less aware of the cost of their convenience. This is akin to the way the internet was initially seen as a tool for democratization, but it eventually became a platform for surveillance and control. The real-world consequences of this dynamic are already visible in the form of data privacy breaches, algorithmic bias, and the erosion of digital rights. The comparison to historical movements against technological monopolies is instructive, as it highlights the importance of vigilance and collective action in the face of systemic power. The road to a totalitarian future is not inevitable, but it is a path that requires constant awareness and resistance. In the heart of the pandemic, when hospitals were overwhelmed and healthcare workers were stretched thin, a new kind of ally emerged. Boston Dynamics robot dogs, once seen as futuristic novelties, found a critical role in the fight against the coronavirus. These agile machines, equipped with cameras and sensors, were deployed to deliver medical supplies, monitor patient vitals, and even provide companionship to isolated patients. The shift from industrial automation to healthcare innovation marked a pivotal moment in robotics. By reducing the risk of infection for frontline workers and improving patient care, these robots demonstrated the potential of AI in crisis management. The mechanism behind these robot dogs involves advanced navigation systems that allow them to traverse complex environments, such as hospital corridors and staircases, while maintaining real-time data collection. For instance, a robot dog could navigate a hospital floor, collect vital signs from patients, and relay that information to medical staff, thereby reducing the need for human contact. The real-world consequences of this technology were profound, as it not only helped in managing the surge of patients, but also provided emotional support to those isolated in their rooms. A useful comparison can be drawn with traditional delivery methods, where human workers were at higher risk of infection, whereas robot dogs offered a safer, more efficient alternative. As the world continues to grapple with the aftermath of the pandemic, the integration of such technology into healthcare systems is likely to grow, reshaping the landscape of medical assistance and patient interaction. Weeks of tinkering with AI tools have left me questioning their true value. As a part-time developer, I've leaned on Cursor and Copilot to explain codebases in seconds, but the speed comes at a cost, skimming over the deeper understanding that keeps me from getting stuck later. The debate isn't just about efficiency. It's about whether these tools are helping me grow, or just letting me fake competence. In a world where time is scarce, the line between practicality and long-term skill development is getting blurrier. The real question is, are we building better habits or just faster shortcuts? What's next for AI and development workflows? How will this shift affect the industry's approach to learning and productivity? This week, a new development in Flutter development is shaking up the landscape. Kaisel, a Dart 3 native router for Flutter, is redefining how apps manage navigation. Unlike traditional routing systems, Kaisel treats routes as values, allowing developers to define navigation paths as data structures rather than code. This shift simplifies app architecture and makes routing more flexible and maintainable. The impact is significant, especially for large-scale applications where route management can become complex. By treating routes as values, Kaisel enables developers to build more scalable and testable apps. This approach also aligns with modern software practices that emphasize declarative programming and separation of concerns. The mechanism behind Kaisel involves parsing route definitions as JSON-like structures, which are then dynamically resolved at runtime, reducing the need for boilerplate code. Real-world consequences include faster development cycles and reduced maintenance overhead, as developers can manage routes through configuration rather than hard-coding logic. A useful comparison can be drawn with React Router, where route definitions are similarly treated as data, but Kaisel's native integration with Dart 3 offers performance benefits. As the Flutter ecosystem continues to evolve, tools like Kaisel are setting new standards for app development. Developers should keep an eye on how Kaisel integrates with existing frameworks and how it influences future Flutter updates. This week, we're diving into the world of Charlie Stross, a prominent science fiction writer and technologist, who recently shared his thoughts on the non-use of AI in his writing process. Published on August 1, 2026, his piece on Hacker News sparked a significant conversation, earning 101 points and 75 comments. Stross, known for his critical views on technology and its societal impact, has long been a vocal figure in discussions about AI's role in creative industries. His stance on avoiding AI tools in his writing highlights a growing divide among creators, those who embrace AI's potential, and those who fear its encroachment on human creativity. For writers, this debate is crucial as it touches on the very essence of authorship and originality. The broader industry is watching closely, as the integration of AI into creative workflows continues to evolve. What's next? The ongoing dialogue around AI's role in creative fields is likely to intensify, with more writers and technologists weighing in on the balance between innovation and authenticity. Stross's position is not just a personal choice but a reflection of a deeper concern: the preservation of human creativity in an age where algorithms can mimic, but not replace, the nuanced, emotional, and often unpredictable nature of human imagination. The real-world consequences of this divide are already visible, with some writers adopting AI as a tool for ideation and drafting, while others, like Stross, resist such integration, fearing it may dilute the authenticity of their work. This tension mirrors the broader societal debate on technology's role in art and culture, where the line between augmentation and replacement becomes increasingly blurred. As AI tools become more sophisticated, the question of authorship and originality will remain at the forefront of creative discourse. This week, a new approach to machine learning is gaining traction, known as explorative modeling. The core idea is to train models not on a single dataset, but on the best of k-guesses, essentially the top-performing models from multiple iterations. This method has emerged as a response to the limitations of traditional training techniques, which often struggle with noisy or incomplete data. By combining the strengths of several models, explorative modeling aims to improve accuracy and robustness. The technique has already shown promise in fields like healthcare and finance, where data quality can be a major challenge. For instance, in medical diagnostics, models trained on the best guesses have demonstrated higher precision in identifying rare conditions. The shift toward this method reflects a broader trend in AI development, where adaptability and resilience are becoming as important as raw performance. As more organizations adopt this approach, the focus will likely turn to how to scale these models efficiently and ensure they remain interpretable. What to watch next is how this technique evolves in real-world applications, and whether it can be integrated with existing AI frameworks without significant overhead. The mechanism behind explorative modeling involves generating multiple candidate models, each trained on different subsets of data or with different hyperparameters, and then selecting the top K models based on performance metrics. These selected models are then combined or averaged to form a final, more robust model. This approach is particularly useful in scenarios where data is sparse or noisy, as it allows the model to leverage the best aspects of multiple training runs. A useful comparison can be drawn with ensemble learning methods such as bagging and boosting, where multiple models are combined to improve predictive performance. However, Explorative modeling differs in that it focuses on selecting and training models based on their performance rather than simply combining them. The real-world consequences of this technique are significant, especially in high-stakes domains like healthcare, where a single model's failure could have severe repercussions. By reducing the risk of overfitting and increasing the model's ability to generalize, explorative modeling offers a promising direction for future AI development. This week, NASA's Curiosity rover captured images of a strange, honeycomb-like landscape on Mars, sparking new questions about the planet's geological history. The pattern, resembling hexagonal shapes, was discovered in a region known as the Murray Buttes, where the rover has been exploring for years. Scientists are still trying to determine whether these formations are the result of ancient water activity, volcanic processes, or something entirely new. The discovery could provide clues about Mars' past climate and potential for ancient life. For now, the mystery remains, but it highlights how much more there is to learn about the red planet. What's next? Researchers will analyze the data further and possibly plan future missions to investigate these intriguing formations up close. The mechanism behind the honeycomb pattern is still under investigation, but it is believed to be formed through a combination of thermal stress and mineral precipitation, similar to the way hexagonal basalt columns form on Earth. These formations, which are up to several meters in diameter, could have formed in a dry environment where water was present intermittently, leading to the crystallization of minerals in a structured pattern. The real-world consequences of this discovery could extend beyond planetary science, offering insights into how similar geological processes might occur on other celestial bodies, such as the moons of Jupiter and Saturn. A useful comparison can be drawn to the hexagonal basalt columns found in the Giant's Causeway in Northern Ireland, which were formed by the cooling of lava. The Curiosity rover's findings underscore the complexity of Mars geology and the potential for past habitable environments. As scientists continue to study these formations, they may uncover new information about the planet's history and its potential to support life. As Reddit stock continues to decline, its CEO has raised questions about the value of Google's AI overviews, a feature that has been a focal point of recent tech debates. The CEO's comments come amid growing concerns about how AI-driven search results are reshaping user behavior and content consumption. This shift has sparked discussions about the broader implications for digital platforms and the role of AI in shaping information access. For users, the change means more personalized but potentially less transparent search results, while for businesses, it signals a need to adapt to evolving search algorithms. The debate highlights the tension between innovation and user trust in an increasingly AI-driven digital landscape. What's next? Watch for further regulatory responses and how companies like Reddit and Google navigate the ethical and practical challenges of AI integration. Those are the developments that define this week in technology. Which change will have the biggest real-world impact, and which story should Nexora investigate in depth next? Share your view in the comments and subscribe for the next weekly edition.